session with which is primarily a hands-on session with R, and but still I'll give you a bit of basics of what data science and how do you go about doing it. A quick background on myself. So I'm Kushagra. I'm working with dimensionless technologies. I'm an IT Delhi graduate with about 10 years experience in the industry. I've spent quite a good amount of time in predictive analytics, and worked with many organizations. I mean, primarily has been into analysis, and I've helped do the sales of it, pre-sales, and a lot of ground level of predictive analytics as well. So we've done a lot of it in the past 7-8 years, and we started with dimensionless a couple of years back, where we are primarily helping people get into this field of data science, right? So towards the end, I'll take up many questions from your end, the way I did last week, or on Thursday as well. So I'll take up a few questions from your end, and I'll try and answer whatever is possible to the best possible extent. Okay. All right. Now, just give me one sec, guys. Primarily, I'll be quickly giving you a brief on what data science is, who should get into data science, what is it all about, and then we'll quickly, jump into the real hands-on part of it. Okay. All right. So that is what the agenda for the session would be. What is data science? What are the different tools? How does R play a role in there? And we'll quickly talk about the R and start with the case study that we did last week as well on Thursday again. So anybody who's new to data science, try and understand this fact that this field of data science, the field of machine learning, of predictive analytics, AI, all that are all these fields are interlinked fields. All these fields are interwoven into each other. And if you talk of AI is replicating human brain, right? When you talk of machine learning, it's a set of algorithms which is helping you predict values, find patterns in data. So the predictive analytics, which is gaining a lot of popularity today, which is where everybody is focusing on, that field is entirely on about finding patterns from data. So you always are in search of finding business problems and solving the business problems, and when you are trying to solve the business problem, your end objective is to find some kind of a pattern in the existing data that you have, and then using those patterns or insights which you generate from the data, you use that to predict a value for feature, to try and segregate data. Segmentation is allowed. You're doing a lot of things with data, so both supervised and unsupervised learning. One is used to predict where you are maybe numeric data, so that is regression problems. You have classification problems where you're trying to predict in which segment the data would be, or you have unsupervised data as well, unsupervised problems as well. Okay. Then, so if you talk about it's an amalgamation of multiple fields. You have so somebody who's trying to become a data scientist has to look at multiple things. So he needs to understand the domain, the industry that is coming from. He needs to understand the uh, the statistics part of it. He needs to be good at the tools as well, right? So and the most important ability for a data scientist is the problem solving ability, right? So somebody who's trying to get into data science needs to be very, I mean, you need not be an excellent problem solver, but you should have that knack for problem solving. You should like problem solving. It should not be somebody I am a hard, I'm hard coder, or I'm somebody who's keen on a lot of technical stuff. I do a lot of coding. I want to get into that field, and I'm trying to get into the data scientist role, because this is more of a business side of a role and less of a very technical role. So although you will need technologies, technologies will be required to do more on that, but the application of technologies only is to extent. domain and the knowledge of your problem solving, your curiosity about things is something which will be very very important, right? So to just give you a very quick example here, I think I gave you last time also. So Netflix had this that a problem, right, that came up in 2006 2007, where they were asking them to increase the efficiency of recommendation system by 10%, and people were able to do 7-8% in 2-3 months, but to get to 10% it took them 3-4 years, right? Similar things happened with number recognitions. So you have 1 2 3 4 5 6, some numbers which are written, and you're trying to replicate all of that. To be able to do it again, it took a lot of time for people to do it, right? So it's all about finding patterns or insights from data, and statistics is a very important or key skill set in data sciences. These two things are very very important. And who should attempt it? Again, people who are good, who likes problem solving, or people who like problem solving, who somebody who likes problem solving and technical skills to certain extent. Now, what all tools are required? You need to know tools like Excel, which is for simple data analysis. You need to know at least one tool like SQL, so that you can fetch the data from various databases. You need to know at least one data visualization tool, so that you can visualize the data. Even R or Python can be used for visualization. But if you know other tools like Tableau and ClickView, which are pretty good for reporting the data, they can be very very handy. Apart from all of that, one tool must be known for being able to do the modeling of data, or to be able to find all this or apply all the statistics on data. So statistics plays a key role, and to apply that statistics you need some of the other tool: R, Python, SAS, SPSS. There are various of them. Okay, I'm not leaving all of this. Okay, to an extent, to this, are you clear? What is data science? Why do you need it? Those who are new to this session and first time attending it.
Yeah, yeah. Yes,
Correct?
sir.
Okay, all right, call me Kush. I'm okay with that. All right,
By
great.
the way, this is Yash.
Yeah,
Good
yes, I
evening.
I I, I see that. Fair enough. All right. So, okay, why are we talking about it? I'm leaving that for now. Probably because this is not really of there's a bit of theory part of it, and we can discuss that towards the end if time permits. Okay. Okay, now I'm jumping out to R basics quickly. What is R? So those who have not filled the form, again quickly fill it, so I can give you the access to that. So R Studio is an IDE. We're using that, and there are various things in R which are pretty specific to our site, like packages, like data types, and data types and data structures are common in all the languages. So this is nothing but what kind of data is allowed, and then in what structural form are they allowed, right? So vectors, matrix, list, data frames, and various of them, right? So you have these kinds of data structures and data frames and data types that are allowed. Okay. uh, so these are the two things which will be important, and packages is nothing but uh, okay, link is here, those who have not seen this. Packages are nothing but libraries, the way you have libraries in other languages. So you attach a library to your code, and you are easily able to work with that piece of code, right? So when you attach a library to a set of code, right, you all those functionalities which are present in, or the functions which are, or data sets which are present in those that library, they are attached to your code, and you can easily use it, right? Similar thing is with packages, and R has lots and lots of packages, so 10,000 plus packages which you can work with. I think by now it must be 10,100 or 200. I haven't seen it in a while. But there are lots and lots of packages, and each package which is there, that is also being revised every now and then. So there's a lot of, it's open source, user friendly. A lot of community help is there. A lot of development is happening, and all of these reasons contribute to R being a very good tool, right? Again, it's not that only R is good. R is statistically pretty good. You have Python and other tools as well, but R and Python are the ones which are really taking the market by storm. That is where most of the opportunities lie today. So if you're trying to get into data science, if you're pretty new, you can start with one tool at a time. If you feel you want to you look at all the opportunities, then R and Python combined would give you almost 70-80% of newer opportunities which are coming up in the market, and you'll be able to land up a job much easily. So I would recommend go for both the tools, one after the other. Don't jump into all the tools at the same time. Maybe one, then the other. That will help you, help you become better, and your employability quotient will also be pretty high. Okay. Okay, now we are doing this case study. Okay, so I'll just go back to this. Uh, have all of you filled the form? Those who are new also? I've taken away the screen for a minute. Uh, okay. Yes, sure, Sudhir. Thank you so much. Uh, okay, thank you so much. Those who have filled, I'll quickly check up who have filled, and I'll be able to know that. Okay, still I think 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 people have filled the form. I'm not really sure why. Many, I think about 17, 18 people is what I see here, but many of you have not really filled the form. Those who have not filled the form, I would appreciate you can fill the form here on the chat that I've given you on the chat window. I'll quickly give you the access to the uh, access to this. So I don't see Sunny filling the form. Sudhir, I don't think you've no Sudhir has filled the form. Vivek, I don't see your form in there. Uh, Shalabh has filled the form. Saurabh, Sajit has filled the form. Uh, there are two Saurabhs, I think. No, there's only one Saurabh in there. Ravi, I don't see your form. Padmini, I don't see your form. Padmini has filled the form. Sorry, my mistake. Mahesh has not filled the form. Please quickly fill the form. I'll give you the access quickly. Jyoti
I
has
have
not.
filled the form.
Yeah, yeah.
No, so
Ravi.
please
Okay, sorry.
be
Ravi
here.
has. Sorry,
I
my
have
fault.
filled the form.
Correct, correct. You have filled the form. My
Yeah.
fault. So I keep missing out a lot of that. Uh, Jyoti, Gaurav have not. Gaurav has filled the form. Sorry again. Anuj has not filled the form. Quickly fill the form, guys. Uh, I'll quickly give you the Excel and we can get started. Okay, Anuj has filled it now. Yash has filled it now. Okay, great. Okay, quickly see my screen. Those who have filled the form, you can see this. You can use this. The link that you have to use for this is Vivek. You filled it. Okay, a little later. And the link that we have to use it uses this. Just a second. I'll give you the link as well. Yeah. So use this link to access the lab, which is the cloud-based lab here. Uh, Jyoti, have you filled the form? I don't see that. Logged in. Okay, all that great. Uh, all right, everybody has got their IDs and passwords. This is your mail ID. This is your ID and this is your password. And for the name of the candidate. Okay, no problems. Uh, okay, all right. Let's start with the analysis now. So again, you need to know the link to the code, which I'll have to give you. Okay, so we talked about vectors. Who is going to explain me vectors today? A lot of you who were there in the session last time. Quickly, who can explain me vectors today? What are vectors? Yes, Saurabh. Anybody who can explain me vectors? What are they? Okay. Uh, I've got one answer. Anybody else would like to answer?
Okay, vector is kind of same type of data of one type.
Okay, it's a
It's
correct. Go on.
its array.
Okay, a
Yeah.
vector is primarily a one-dimensional array. So vector is one
Mm.
of those data structures which are present in R. And when you have to work with vectors, you will be uh, you can you can work with vectors. And how do you work with vectors? It's simple one-dimensional array, and we've seen a few questions on that as well uh, last time when we were working with that. So I'll quickly do this. This is how you create a vector. Right? A vector is created with a value a. The name of the value vector is a, and this is the value that is contained in the vector. Right? I can put multiple values in a vector as well. So this is how I'll do it. Uh, so when you say a of this, now this a is okay. Again, it's getting loaded there. Now if I have to print a, now I know that these are the values which are present in a, right? Then we did this simple subsetting of a vector. And how did we do that? We said if we wanted something in a certain position, we can give the position number again using square brackets, and we'll be able to get the output accordingly. Okay, so we've got it like this. So 30 is present in the third position of this. Okay. Uh, Similarly, if you want to work with some logical vector, you can use logical vector as well. So true and false are logical data which are present in the uh, present in this, right? So when you have to work with that, you'll get a logical vector, and with that logical vector, you'll be able to get to the output. So if you run this here, you primarily get 10, 30, and 40, which are your which is a so you've passed a logical vector, right, to this variable a, and wherever you have true, is that value is given to you. The rest of it is dropped. Okay. uh, all right, so I see Deepsika and Jyoti. Have you filled the form? Still not? Okay, so we had done this question, correct? No problems. Okay, I'm not giving you any questions for vectors now. um, so hopefully you should be able to understand this better, right? So when you have to work with multiple data points, I said you need to use the C function, correct? You need to use the C function to be able to work with multiple uh, multiple data. Okay, all right. Coming back here, so this was a simple vector, right? How do you create a vector, which is the simplest of the data structures in R? And then we went ahead and talked about this data, right? So I've given you the link to the data. Everybody has got that link. Those who are new, so I've given you the link uh, for these data, and also link for this lab. All of you have got that? Quickly, yes, no? Okay, all right, fair enough. Then I talked about this data, right? I told you there are a lot of data sets which are already present in there, and we had worked with this data, right? I'll quickly go up and see this data, and I had stored this data. So this is where my data is present. And if I do a control J here, um, one sec. Yep. All right. So you can see this. These are the various variables that we had, and we had imported this data. Right. We understood about various things. So we did univariate analysis on this data. Okay. What was univariate analysis, and what did we do? Anybody who remembers that?
We did mean, mode, and medium.
Okay, median mode is the measure of central tendency, right? So whenever you're trying to do when you're trying to understand about data, so primarily univariate analysis is to understand about the data, right? So your job is to understand what kind of data is there. Okay, we did okay, there were steps to do the univariate analysis. But what is univariate analysis? You're trying to explore one variable, right? And why are you trying to do the univariate analysis? Why do you do univariate analysis? Why do you explore one single variable at a time?
To understand its dependency.
Okay, will that give you the dependency? Will univariate analysis tell you the dependency of that on the dependent variable? No, right? You're only exploring one variable. How would that give you the dependency? Okay, it also does not determine whether it is categorical or continuous. We would try and figure out whether it is categorical or continuous. That's our job. What else? So univariate analysis is to understand, say, one single variable, what kind of data is present in that variable. For example, my
And what kind of trends are there in the data?
correct.
So like univariate analysis is to, like, we try to understand the data and from a single variable point of view, and uh, how that particular variable is affecting. So
Again, affecting
doing a
what?
trend.
When you say when you do univariate analysis, it will affect what?
Well, like we are looking at the data to solve business problems. Okay, so when we are doing a univariate analysis, then we are trying to understand the mm, the effect of the variable on maybe
No,
on the business problem.
not really.
No?
Okay, okay, not really. To some extent, you're right, but not entirely. So when you do univariate analysis, you are primarily trying to understand uh, the data. Say, for example, you're saying one variable, right? So here, this variable is current credit balance. This is the current credit balance that you have as of now. Okay. Now you are trying to explore this variable. Now, to be able to uh, understand in general what is the current credit limit of the data set that you have, right? Do you have some exceptional values here? Do you have some values which are outliers, right? You can understand that. Or you might also want to understand if there are some values which are uh, yeah, if there are some values which are okay, sorry. So some values which are missing there, right? So some values might be missing, some values are junk values. Is the data properly put in or not? What kind of a distribution this data follows? And then, so you have this data, right? Then you try the idea of finding the mean, median, mode, or the standard deviation is only to understand what kind of distribution this data is. So when you understand the distribution, you understand the property of that data. You try and understand more about that variable. You know, in terms of, do you have some values which are really not good enough, or do you need to change that data point to some values which are important for your analysis? All right. Understood. Why do you do univariate analysis to some extent? Okay, frequency of that data will be for categorical data, right? So you generally have two kinds of data. What is categorical data and continuous data? Anybody who can explain categorical and continuous data?
Categorical data is like, when you have a data from a limited set of values, like for example gender, for example color of the car or something like that, and
Okay.
a data which is numerical in nature and can take any value
Hmm.
is other type of data.
Okay.
For example, the ID and other things,
Okay.
or name.
Name is what kind of data?
Name is Name is not categorical kind of data. Name
Name
is,
is
a
name.
data which is general doesn't mean in much in trend analysis.
Oh, that's a different thing. But what kind of data is it? Is it categorical data or continuous data? Okay, let's do one thing here. Okay, you understand categorical and continuous. So I'll explain once, and then for those who are new, categorical is data. Data is data which can take only certain fixed values, right? So name is out of some value. You can give any name, but that would be again categorical in nature. There will be some category. It will not really ideally you what you said is also makes sense that name per se would not have an impact on the trends on whatever it's because it's only an identifier to a certain individual or to a certain observation, but it does not really mean anything, right? So it's only an ID kind of a stuff. uh, if you talk of categorical data, as you said, gender, blood group, your color of the car, all that could be your categorical data. uh, Similarly, if you have data which is numeric in nature, where if you take a set of data and you apply some numerical observations or arithmetic operations on that data, it starts making sense. Then that is my numeric data. Okay, that is my continuous data. Again, continuous means it's there on the time series way. It is there in the axis, and you can do some kind of analysis on that. When I say analysis, it's primarily the arithmetic operations, and it should start making sense of that. Okay, everybody has got empty cards with you. That's present with your data, right? I told you last time also. So just check for empty cards dollar gear, empty cards. Um, okay, how why dollar is required? So to be able to pull a certain column from your data frame. Again, I'll talk about data frame to those who are new. So data frame is another such data structure which R allows, and it allows you to take two-dimensional data. And that when I say two-dimensional, it is n cross m form, and it will not just allow you one data type, it will allow you multiple data types. Okay, so that is what your data frame is all about. So it's like a tabular data. If you have seen a database and or simple Excel which is tabular in nature, and you can have multiple variables, that's how your data frame looks like. Okay. Okay, empty cast dollar gear. Ping me, is it categorical or continuous? Yes, quickly. Expecting an answer from everyone. I've got only 3-4 people who have answered. Are you not really clear about it? Okay. Okay. Deepshikha and Sunny, you were asking for the links. I've sent you the links of the form on the chat window. Please, you can look at that as well. Uh, okay, so please fill the form if you've got the link. Okay, so many of you are saying it is categorical. Many of you are saying continuous. Now, how do you decide whether it is categorical data or continuous data, right? If I print this value here, right, it is 4 3 4 3 4 5, right? Whatever, some 3 4 and 5 values. Can you have a gear like 3.5 gears in your car? Can you have 20 gears in your car? Sunny, I pinged it to everyone. I'm sure you got it. uh, if you could scroll up, you will certainly be able to figure that out. On the chat window you'll have it. Okay. uh, so now tell me, this is I told you 3 4 and 5. There are 4 gears, 5 gears, 3 gears. Can you have uh, any new decimal values for your gears? Is it possible?
No.
Generally you have only certain fixed values for your gears, right? Your car can have 1 gear, 2 gear, 3 gear, 4 gear, 5 gear, or 0 gear. Correct? isn't it? You'll have some number of gears, right? The number of categories which are involved there is no. So Deepshika, you would need to fill that form again. I'll have to give you which ID you're using. If you're using guest 15 again, somebody else might be using it today, is what I meant. All right, coming back here. So this is a categorical data. This is not really a continuous data, because again, how do you understand that better? How this is a categorical data. This is not a continuous data. Okay, although the data seems numeric, but this is a categorical data because you will have only certain categories, certain fixed values that this number of gears a car has can take. This variable cannot take just about any value, right? You cannot take a continuous value there. You cannot plot it on the number line. You will, when you draw a histogram, right, it will be number of threes, number of fours, number of fives, isn't it? See, continuous variable is continuous. It's not discrete, right? Numerical can be continuous or discrete. Numeric data can be continuous or discrete. The discrete data is categorical data. A continuous data is a continuous data. It's as simple as a time series kind of a data, where you have time on the x-axis and the values on the y-axis. Okay, so sorry, don't get confused with the numeric and non-numeric. Okay, so discrete and continuous is what we are looking at. So this is your categorical data. How do you understand more about it? So if you do some kind of arithmetic operations on your data, say one car has 5 gears, the other, or you have 10 cars, and the average number of, you cannot say average number of gears in this car is 3.3. Can you say that? Will it make sense? No, right? I have 10 cars, some of them have got 4 gears, some of them have got 3 gears. Say if I do some kind of addition or average of that, maybe it comes out to be 3.4. Will it make sense? 3.4 gears per car? No, right? So that's your categorical data. Clear? The name is a string data. Name is not a numeric data. See, continuous is numbers. It cannot be a so string data is generally categorical. Whatever you have strings data, string will always be categorical. It will never be a continuous data, right? Because each string is an individual identity, and any arithmetic operation on strings will not bear you anything, right? No, it will not make any sense, correct? All right, fair enough. So clear, continuous, categorical. Everyone now, those who again first timers also. Sunny, I think you joined the last session as well, right? So I'm just revised that. I have not started with anything. Okay, one sec. After you asked, I ping you the link then only, man. Just give me one sec. And that is where the distraction is. Okay, so I've pinged you the link. Please check now. Okay, fair enough. Coming back to this now. So now we said we want to explore this data, right? How do we explore this data? First of all, we'll do the univariate analysis, which is understanding this variable. I think still you've not understood univariate to that extent. So I'll do a lot of univariate today first, and then I'll go to bivariate. Okay, let's see how much we can do. So the idea is to make sure that whatever you're learning it well. Okay, it's not that I can teach you everything, but to some extent, whatever we are learning, we'll try and learn it to the best possible extent. Okay, so let's do the analysis of this data, and this is what you have. Okay, all right, so I have got, so whenever you look at this data, okay, this data is all about credit history for certain individuals. Again, for the new people, so I have got about 1500 rows here, right? And I have got data for people who have taken the loan, and either they've run away with the money, they've not really paid back, and some people have paid back to me, right? So I'm trying to figure out, is there any kind of a pattern or analysis I can do to understand what kind of people run away with the money, so I don't really give them the money, right? I'm not really hell-bent on having a fixed rules for things. I'm trying to understand more about the patterns which exist in the data, and then using those patterns I'll try and using that pattern will try and do more on the more of the analysis, right? So we'll be able to take better decisions. All right, so let's get started with this. So this is my data, and in here okay, first thing we did was what is the dependent variable and what is the independent variable, or what is the target variable or predictor variable? What are we trying to predict here? Quickly in this data, what are we trying to predict? Yes. What is the target variable? What is the variable that we're targeting? Loan status, correct, wonderful. Right, whether to give a loan or not. So I would be interested in knowing whether people take the money and run away, right? And whether people give it back, right? So I'm trying to find patterns which will help me understand this, right? So what is the dependent variable here? The loan status, correct? And then there are a lot of independent variables like loan ID, uh, customer ID, you have credit scores, year in current job, home ownership, annual income, right? Years of credit history available, number of credit problems they have had, current credit balance they have. Again, I had a lot of variables here. I've reduced them to only few of here, right? Okay, so and this is current loan amount, right? So there are a lot of variables that I have. I'll try and analyze this, right? So let me first import this data into R. Okay, everybody is able to access the lab. The link for the lab was lab.dimensionless.in. You'll be able to access that, right? So this is the lab. Access again, those who are new can access the lab here. Okay, one sec. So you can use 13 and 14 and 15 rather 14 and 15. Okay, guess 14 and guess 15 is what you can use. I hope that is okay with everyone, both of you, Deepshika and Kushal. Okay, all right, coming back here. Now I'm trying to import this data first here, and then we'll be accessing this. All right, so to be able to import this data, since this is a CSV file, again there are various kinds of file. How do you work with databases, Excels, your flat files, JSON files, HTML, and there can be various other kinds of NoSQL data. How do you access all of that? There'll be different functions, different ways to do it. We are handling a simple CSV files for which we're using this simple function read.csv. And again, this data is present on the web in this link. So I've just passed that link here to this data, right? Those who don't have the link, I'll just ping this link again. Although I pinged it only a while back, but I'll just ping you once again so that you can take the data and read the file, right? Once you read the file using read.csv function, you are storing the file in this data, which is data function. Okay, now this data was what type? Yes, Sudhir, what kind of data it is? Tabular data? Yes, no?
Absolutely, yes.
Correct. This is a tabular data. And do you have only one kind of data type or multiple data types here?
Yeah, multiple data types.
You have string as well, you have numeric as well, right? You have multiple data types here. Correct. Correct. So you have multiple data types. So when this gets imported into R, what kind of data structure format it will take?
I'm sorry, come again?
Okay, so once it is imported into R, it will take some form of a data structure. Which data structure form will it take? Okay, it will take a data frame. It will become a data frame. Clear?
Okay.
Okay. Yes, it'll become a data frame now. All right. Now, if I have to understand what data structure, I can see the structure of this. Okay, simple structure str function of this data, and this will tell me what this is. Right. I'll just explore this here for you. You see, it tells you this is a data frame which has 1,487 observations. Observation means rows. 12 variables means 12 different columns. Okay. And these are various data types, right? So it is either factor, it is integer, again factor, numeric, integer, right? Again, I'll talk about what factors are a little later. So it's primarily, okay, let me just tell you. So when you talk of factors, it's primarily a way to handle categorical data in R. So if you have categorical data, you'll be able to handle it well using the uh, categorical data. I mean, using the factors, right? So if you have numeric data and you still want to have it as, so for example, this has taken it as a integer data, right? Number of credit problems, which again, so if you have 10 people and you say number of credit problems with that is say average credit problems is 1.5, which is okay, right? Out of 100 people, you have on average 1.5 credit problems per individual, right? So you, that still would make sense, right? But if you want to consider that as a categorical data, also you want to segregate people who have 0 problems, 1 problem, 2, 5, 10 problems, you can still do an analysis on that, isn't it? So this number of credit problems, this variable could be treated as continuous as well as categorical. You need to decide how do you want to do the analysis. Are you there with me, everyone? Correct? Okay, great. So let's move on. So we have imported the data. Now we'll try and do the analysis of this data, right? We'll try and do simple analysis first again, and we'll try and know more about it. Okay, so to be able to do simple analysis, let's take one simple variable, and that is my, say, loan status for now. Okay, so, or rather, let's do this too. First, these two. Loan ID, this is unique to every individual. Okay, yes, you need to answer this. Loan ID is unique to every individual. Can I, can I find some kind of a pattern, or will this loan ID have some impact on the loan status, whether somebody runs away or will actually pay me back?
No.
No, right? Why?
Yeah. Because the loan IDs are unique. They are not interlinked with the other data.
Correct, they're not interlinked. So this is an independent entity, right? It's just an identifier for that individual.
Correct.
Now, even if I find some pattern with loan IDs with people who have taken away the loan, that is a purely coincidental thing, right? Because it does not have any bearing. Okay, you might find some correlation. Okay, you say, okay, these kind of people have, have taken the, I mean, these loan IDs have actually defaulted, but it's something which is coincidental. Also, you might find, so that is called correlation. I'll just tell you one more example of correlation as remembered. So there's a theory given by Thomas Friedman. He's a very well-known author who has written this book, The World is Flat. Okay, in that book, he said golden arcs theory, 2 arcs. So he in that theory he says um, that no two countries who have McDonald's in them. So two countries who have McDonald's, they have not gone to war with each other. Okay, now countries having McDonald's and actually going to war or not going to war with each other is it's purely coincidental, right? You don't have any relationship between whether you have McDonald's or not, and whether you will go to war with the other country or not. Primarily because those countries are open to globalization, or countries which are allowing investments and stuff. They're reluctant to go to war. Probably that is the reason why they're not going to war, right? Is it? So there might be a few exceptions, but mostly that was following through. So that kind of correlation came up with the data, but actually does not make sense. Clear? Are you all with me? Similar thing can happen with loan ID or customer ID. These are simply identifiers, and they will not really they'll not really mean anything whether you find some patterns here or not. Okay, so we'll directly go to the loan status. We'll try and start the analysis from this point. So if you look at loan status, what kind of analysis you can do here? This is a, okay, I'll do one more thing here. So I'm applying a function. You don't worry about it. So it's sapply function. Okay, and I want to apply it on data, and I want to know the class of each variable. Okay, I can do that. So when I run this, it'll tell me what is the data type class of each variable here. So this is it says this is a factor. Loan status is a factor, so it means it has taken it as a categorical data. Okay, factor is used for categorical data, so it means this has taken it as a categorical data, so I don't have to worry about whether it is categorical or continuous. Although I know that this is categorical and it's taking the same thing, hence we are on the right track. Okay, so using now I have applied class function, right? I could have applied any other function also on this data, on each column of this data, by using this sapply function. So if I wanted to say convert everything to say everything to integer or everything to numeric, or I wanted to know the the structure of everything, right? So you can apply any function on each column of the data frame using sapply. Okay, just giving you a quick overview. Not really would have a time to discuss much on that, but you can do that, right? Now coming back to this loan status here, so you have two data points. So now we'll try and explore this. So if you want to explore this data, uh, since this is already factor, so we can easily check there's something called levels. So I can say levels of my data, which column I want to select. So dollar, then the column name. What is the column name? Loan dot status. Okay, so if I check this up, it tells me there are two levels, charged off and fully paid. Okay, it tells me there are two levels in this data. All right, I could, if this was not factor and I wanted to convert that to factor, I could have easily done that, and that I could have done using this function. So as of now it is a factor, so I don't have a problem. But if I wanted to convert that to factor, I could have said as dot factor on this data. Say again, don't worry too much about what I'm doing. If you're able to follow through, great. If not, don't worry. Just understand I'm converting this loan dot status to a factor variable. Since it is already a factor variable, it will not really be, sorry, I'm trying to access this loan dot status.
Does this work like casting in SQL?
Frankly speaking,
Wait.
not really too comfortable with that. Okay, so I use SQL only to a certain extent. Always been into the the core part of it. So what you're really trying to do, you're trying to access an entire column here, okay, and you're trying to convert that to a simple as dot function, which help you convert that. Okay, now this is a factor again. Already it was there. If I wanted to convert it to something else as well, I could have done that. So now levels, right? I got the levels as well, charged off and fully paid. These are two different levels with my data. And if I have to know more about that, I can use this table function. So if I do a table function, or I can also do a summary, right? So if I do a summary, I talk about summary also in later. I mean, again, let me do summary here for now. So data dollar loan dot status. Okay, so if I run this,
Letter A is missing.
sorry, A is missing is what it said, and I've got the data now. It is telling me charged off is 355 and 1132 is fully paid. Now this is a factor, hence summary gave me the output like this. We'll try and understand if it had been a numeric data, it would not, had it not been a factor, the solution would, the output would be very different, right? Now again, similar thing could be achieved with table function as well, right? Okay, now I'm again using another simple way to plot this data, and if I use say plot function here, this is how the plot looks like. Okay, charged off and fully paid, these are people who have taken the money and run away, and then some of the people who have paid me back. Okay, similarly I can do the current loan amount, right? Let's do that. So if you look at this data, current loan amount, I can directly apply the summary function on this, and I can create a histogram. I can do so many things with this, right? I'll do few analysis of that. So I think we could not do a lot of it last week, so I'll try and do more today. So suppose I'm running this summary function on this column. Now I'm working on this particular column, which is here, current loan amount, right? You could do it on similarly on other columns as well. So if I run summary, what will tell me? It'll tell me few things, which is minimum value, first quartile, median, mean, which is average, third quartile, and maximum value. Okay, we talked about this last week. So we said minimum, maximum, you got some value, first quartile and third quartile, you know, median and in mean, you know, right? Now, just by looking at mean and median, we could know what kind of distribution it is, right? Had they been equal, probably it would have been a normal distribution, right? If not, there's some kind of a skewness here, and that skewness is again in the positive direction because mean is more than median. First quartile, third quartile, everybody understands. So where you, if in your data, suppose you had 100 data points, the moment you enter 25% of the data, that is your first quartile. When you hit 75% of the data, that is your third quartile. Okay, clear everyone? First quartile and third quartile. So when you hit 25% of the data, that is first quartile. Third quartile is 75% of the data when you hit, right? Now, if I have to do more analysis on this data, I could do another analysis on this, which is, say, I could have drawn a histogram, which I did last week also, or so in the last session also. So that I did here using hist function. Okay, now it tells me that the data is spread here, right? As of now, since I've already taken a very small chunk of data, I really don't see a lot of outliers. Maybe if I had outliers, they would have, you know, this data might have been here, and there might be few extra data points here towards the end. There might have been few extra data points towards the end here, right? And you would know that this is where the problem lies, right? So you would know that if there are outliers in your data, either here or on the extreme here. So outliers are nothing but extreme data points, right? Now, if you wanted to do that analysis directly through this, you could have done it using another set of command, and that command is this. So I can say, let me just say outlier, and I can say simple box.plot.stats. Again, this is okay. This is another function that we're using. Okay, and on which data I want to apply? Data dot dollar loan. Sorry, here I want to. Okay, leave this here. Okay, coming back here, right? Now it is telling me I can apply this box dot plot dot stats, right? So box plot dot stats is what I want to apply. This function, once I apply on this, I will get more analysis on this data, right? So if I run this, I've just printing this variable, right? This is how I print this variable. Okay. Okay, now it is telling me what does it contain, right? So if you look at this, it tells me this is the minimum value, first quartile, the median, third quartile, and then maximum value. Okay, that is one analysis I've got with this data. Number of data points I had was 1487. Then this is the confidence interval. So it says, okay, again, forget the confidence interval for now. For if you have some kind of analysis where exactly the mean would lie, if you look for some value, so forget it for now. Again, I don't think I'll have time to explain this at depth. So it is after intervention, what will be the new mean, where exactly the data should lie, what is the probability of data lying at certain point. So this is primarily your 95% confidence interval. So this is what it is giving you, right? Then it is telling you if you have outliers or not, right? So it is telling you you don't have any outliers. Okay, do you have outliers here? You don't have outliers here, right? Integer 0 means there is no value which is an outlier, because probably I've taken only a chunk of data which really does not have any outliers. Clear? If I wanted to know more about it, I could have taken the length of outliers. I could have known more about it. Suppose there are a lot of outliers here. I could have simply taken the length function. I was talking about that also, right? Last session, where I said if you want to know more about the number of elements you have in a variable, so you could have said length of which variable. So the outlier is a list. Okay, again, forget what it is for now. But if I want, I can access it like this. List is another data structure. So this is a data structure which is of the form list. So if I plot it here, if I run this here, it tells me it will be 0. So there are no elements which are present in this data. So no outliers which are present in this data. Again, if you had outliers, then you need to understand what kind of treatment you could do to the outliers. Whether you want to cap them, you want to remove those values, those data points, or is there a typing mistake? Do you want to do some kind of averaging on that? I mean, there are various ways in which you could treat it. Again, not really possible to cover everything here. Okay, can you quickly do a analysis of the term? The term variable, everyone. So I would want you to do simple term variable and the next one, which is credit score. These two, quickly do that, and then we'll move on to the bivariate analysis. Now there could be a lot of problems with the data as well. So in terms of the data might not be clean, you might have some symbols in there. The list within cleaning also, you have so many things which needs to be done, right? The data structure is not correct, the values are not really in place, missing values are there, outliers are there. Again, all of that will come into cleaning as well, right? So that also you need to do when you're understanding about this, right? So here you've drawn a plot here for this data and you got the plot like this, right? Similarly, quickly do the analysis for term variable. How would you do that? Will you be able to do that now? I've told you a couple of them. Simple univariate analysis of term and this credit score. Anybody who feels he'll not be able to do, he or she will not be able to do, please let me know. Plotted histogram, term is a factor variable. What's the other column name? Other column name is the next one, which is the credit score. Yes, guys, done. Quick yes, no. See, you have to do it by your hand. That is where you learn. I can do hundreds of that every day, but would not help you, right? You need to perform it with your own hand, and the more you do that, the better you will be getting at that. Okay, fair enough. So I'll quickly do that as well now. So you have we want to know about, there are outliers, okay. credit scores also, and we'll see this also, right? Short-term loan. So again, I'll just copy this, copy pasted code, and rather than repeating everything, sorry, this is got right. Now you want to work with term. Yeah. So let's understand what are the levels. So you have got long-term and short-term, two levels. What is the so 440 people have taken the long-term loan, and about so long-term loan is 440 people and short-term is about 1047 people, right? Again, if I try and draw a plot, it will be simple data here, right? It's a bar, it's a bar graph. It's not really a histogram, right? So this is a bar graph because each category is independent. The shape of that will not really matter the output. Okay. When you do bivariate analysis, then it will be handy, right? We'll talk about that in a while. So this is the summary. Okay, not really. I didn't want to do this. I want to do it on credit score, right? Credit dot score. Yeah. Dot score here. Yeah, same variable I want. Now I've got credit score. 585 is the minimum value. First quartile is 703. Median is 723. Mean is 720. Third quartile is 740, right? So again, let's see this. If I draw a histogram here, mean and median are pretty close to each other, right? So median value is 723, mean is 720. So with this, you would not really expect the data to be skewed, but still, if I see there's a lot of negative skewness, right? Obviously, mean is less than median, but I was not really expecting the skewness to be so much. But seems like there's a lot of skewness in this data, and skewness is from the normality, how much it deviates. A normal curve is this. This is simple. Okay, again, my pen is not there. Give me one sec. This is your simple normal curve. So the more the variation from the normality, the more is the skewness from the curve. Here, if you look at this curve, this is a skewed curve, right? So you have a lot of data which is lying here on the left. Okay. All right. Coming back here. Now, this is my histogram, right? It tells me there's some issue with this data. Let me figure out if you have outliers in this data, right? And if I print this outlier here, it will explain me. Okay, these are the outliers. So anything which is less than this. So how do you calculate outliers? Okay, so what you do Q3 minus Q1. So this is a simple formula. Just give me one sec. Yeah. So how do you calculate outliers? Now I've got my pen. It will be so much better to write here. So you've got Q3 minus Q1, right? This is your IQR. Using this interquartile range, we'll be able to figure that out. So this is called IQR, right? Now from Q1, if you move 1.5 IQR, you'll be able to understand whether you have outliers in it. So in general, you can decide the outliers like this. So Q1 minus 1.5 IQR, any value which is less than this, Q3 plus 1.5 IQR, any value greater than this, that will be your outliers. Okay, for now it is 1.5. I can decide what it will be. I have the option to decide that as well. Okay, so when I'm creating a histogram or when I'm creating a box plot, I can do that. Let me just show you how do you create box plot. Are you good here? Anybody has any questions? So this is the formula which you use to create to figure out if you have outliers in your data. Okay. I wanted to use the green one. Yeah, this is so much better. All right, great. Now, if you have to create a box plot, again, I will just create a box plot of the same data. I'll tell you how that looks like. Right? So if you can say box plot, and you can simply pass this data. Let's see. Like if you do this here, forget this ggplot2 for now. Now you see you've got the data here. If you zoom this up, you see these are your outliers values, which are so 800. This is 1 point. You don't have any point here, and then less than 650. Again, you have a lot of outliers, right? That's what it is telling you. Now you really don't want the data to be 1.5 IQR, because your IQR is a pretty small range, which is say Q3 minus Q1, which is about not really a lot of values here. So you want to change that, right? You want to make it 2.5 IQR. So you can use this value range is equals to 2.5. Now if you draw the box plot, see the box plot has suddenly changed. And if you zoom it up now, okay, now you see this has moved up further, isn't it? This is called whisker. Okay, this box and whisker plot, this is called whisker. Now the whisker has moved from here to here. It has extended itself by 1 IQR on either side. And now it is not 650 where you have outliers. It is rather say some other value. Okay, which is nothing but IQR, right? So wherever you hit the IQR, you will have the value there. So all these values are your outliers. Clear? Any questions, confusions, anyone? Thank you, Shalab. Anybody, Deepshika and others, any question? Are we good? Can we move on? So you can create the visualization, you can do the analysis there. Okay. Now let's quickly move on and do the bivariate analysis, right? Now, why do you need bivariate analysis? Anybody who can answer this for me?
There's sometime like your problem is dependent on like more than one variable. Like looking at only one variable will not give you the right picture. For example, the like example we are looking at, so probably it will make more sense if we are looking at the credit score plus like plus how many times they have credit defaulted and what kind of loan they have taken. So that kind of like 2 or 3 variables together will make more sense on whether
Correct.
they default on loan or not.
Correct.
So
Correct.
univariate sometimes is not the best way to go. It's
So
good for trend analysis.
univariate is to understand the data, right? Univariate is always important so that you know what kind of data it is. You can clean your data. You can do so much more better with your data. Once that is done, then you move on and do the bivariate, using which you will be able to find the pattern, right? Univariate is not really helping you, find the pattern in the data. Okay.
Between two.
Now bivariate is having the relationship between two variables. Okay. Now what exactly it is and why do you use that? Let's quickly see that up as well. Okay. So if you want to do bivariate analysis, right? If you want to do bivariate analysis, what we can do is we can how would we do that rather bivariate analysis is we'll take a set of data, right? We'll try and so exactly what you said is bivariate analysis can be done in so with the dependent variable, how the dependent variable varies or has some kind of relationship with the predictor variables or the independent variables. Do you see there any relationship between those two variables or not? That is one way why you would need that. Plus, so many a times what really happens is you would not really see a relationship between the the predictor variable and the the variable that you have, the dependent variable and the predictor variable, and the relationship actually might exist uh, between the transformed some kind of transformation if you do to the independent variable, and then that transformation, maybe it is it is the squaring of that value, or taking a log of that value, or any kind of transformation that has a relationship with the dependent variable, right? So it's not always a linear regression, right? It might be some kind of a relationship, but you would not really know that until unless you find out what kind of relationship exists between those two variables. Okay, that is one. Plus it will also help us, so if you understand that well, so if you try and do the analysis, so there's something called underfitting of the curve and something called overfitting of the curve, right? Again, I'll give you at a very high level what that is. So suppose you've got a set of data, right? Say here I've got only 1500 observations, and I try and create a model which is able to kind of go through almost all the points here in the variable, right? Correct. I have created a model which is able to go through almost all the points here, and consider each point is on in 10 dimensions. I have 10 variables, so it will be in some 10 dimensions. I'll have that point. Right now, your data point, or your the line or something that you're drawing, or the surface you're creating, that's there in all those 10 dimensions. Obviously, humanly will not be able to to understand what it is, but with the analysis you'll be able to get to understand that, okay, this point is covering almost all the points, right? Now our aim is not to just look at this data. We want to generalize our prediction, right? We want to make sure that if a new data comes up, my data should be able to, the model that I'm creating, it should be able to predict for that the new data as well, right? For my data, whatever I have, I've created a model, that's okay. But this data, if it is not working on the newer set of data, it really does not help me out, right? Because at the end of the day, I'm trying to do the predictive analysis for some unknown data only, right? Some new customer who's going to come up, I need to predict for that. For those old customers, I already know what happened, isn't it? So there, if you try and do overfitting of the curve, which means suppose your data is kind of doing very good analysis with the existing data, you see it's 95% accurate or 98% accurate, which is a pretty high level of accuracy. But when you take a new set of data, it comes down to be, say, only 30% or 40%. So certainly you have overfitted the curve, and your data is not good enough. Your analysis is actually I mean it's gone down the drain. It's not really good enough, right? So you would not want to do that. Similarly, you would not be able to do underfitting also, right? You would not want to do your data is not really, the accuracy of your model is pretty low, and again the subsequent when you do it for the new set of data, that again will be pretty low. So both the cases you need to find a match there. You need to get to a level where both of them collide, and both of them intersect in such a way that you get an optimal fit. Okay, neither overfitting or neither nor underfitting the curve, right? The one that you have for the data. Okay, so bivariate analysis will help you do that as well, right? Okay, it will help you understand uh, whether you're overfitting the data or whether you're underfitting the curve, right? That also it will help you do. Okay, there's one very important point here. So when you do when you're working with analysis, when you're doing say simple linear regression, mostly simple linear regression will more often than not give you an exact output, because the relationship being a linear is not really true in most of the cases, but it does give you a very good approximation. That is why you go for linear regressions as well. But having said that, suppose you have I had taken only 10 variables. Suppose you have data for 500 variables. You would not really want to create a model which is so complex that you're taking 500 variables, because there has to be an ease of implementation as well. Correct? A banker, if he has to implement a model, if he has to figure out the data, he might not be able to collect all those 500 variables from that new customer which is coming up, right? So there has to be a balance which has to be exercised, or which has to be created between the number of variables you're using, the ease of implementation, and the the accuracy of your modeling. So there again has to be a certain amount of balance which needs to be created. There'll always be an epsilon, or there's always be an error term which will come up, which which you as an individual or the model can never predict, right? There'll be a certain amount of error which will always be there, but we're not we're not really bothered about that, because we know there'll be certain amount of error which will creep in, and we don't want to be predicting 100% correct all the time. That is something which is very very rare. But having said that, our aim is to create a model which is good enough for analysis, for being able to predict. So you don't really want to take all the variables into picture, right? So this bivariate analysis will tell you, okay, some of the variables are not really good enough, so you can simply ignore that. Or some of the variables are redundant, which means you have taken relationship between the dependent variable and couple of independent variables. So now two variables give you very similar relationships, exactly same relationship, so you can drop off the redundant one. Okay, that is another topic which is called dimensionality reduction. Okay, which is again that's another part of this the machine learning, where you do this dimensionality reduction, and that is also very very helpful, right? And again, as I said, the transformation with the what kind of relationship you have, you'll be able to know more with that as well. Are you with me to some extent? Are you following me what is happening? Anybody who has a question here? Quickly, yes, no? Are we good? Okay, fair enough. Let's move on then. So okay, so let's now this data that you have, right? You can find a relationship between two predictor variables. So it's not always between the dependent and the independent variable. You might have relationship between two predictor variables as well. As I said, that will help you find the redundancy in the data, right? That will help you do the principal component analysis, which is again about dimensionality reduction. That is also there also you'll have a lot of help. So let's try and do a couple of this right here, the bivariate analysis. And when you're doing bivariate analysis, it could be between a continuous variable and a categorical variable, right? So I'll quickly write it up here. See, just a second. Yeah. So it could be between a continuous variable and a categorical data. Um, Again, continuous and continuous, and categorical. Okay. There can be various kinds of analysis that you might have to do. All the three categories could come in, and when based on the categories, you'll be doing the analysis accordingly. Okay, but you primarily are trying to do a lot of hypothesis testing to understand the relationship that you've got. What you've got for the sample, will it hold true for the population or not? Okay, fair enough. Let's take a couple of variables and try and do the analysis here. Okay, so mm, which one should I take? What is the dependent variable here? Let me draw a simple scatter plot here. Suppose you're drawing a simple scatter plot between say data dollar loan dot status and say data dollar, say what is that current loan balance, what was this current loan amount. Okay, let's take this dot dot loan. Okay, you need to understand that when you do the modeling part of it, when you do the analysis, it's not a one time job, right? You'll have to do it multiple times. You'll have to do a lot more analysis on this data, and to be able to understand this data well, right? What I've got, okay, it has given me some kind of a plot here, which is a box plot primarily. But why is it giving me a box plot here? So for charged off, this is how the data varies. For fully paid, this is how the data varies, is what it is telling me. Current loan amount varies in certain fashion. Okay. Suppose I wanted to do a scatter plot here. Just give me 1 sec here. Okay, generic XY plotting is what it is saying. So scatter plot is primarily done when you have both the data as numeric in nature. When you have when you're trying to take one numerical and one categorical data, so it's taking the categorical data in x-axis, and corresponding to that, it is telling you how the data is varying. Okay. So if you have to do, you actually will have to apply a t-test on this data to understand, whether there is any relationship which exists between the two, and if there exists a relationship, what kind of relationship will that be? Okay. So if both the data is continuous in nature, you try and go for correlation. If one is categorical, one is continuous, you'll have to do t-test on that or z-test on that. And if it is more than two categories, then it is ANOVA and stuff. If both of them are categorical, we do chi-square testing, and with that we'll be doing the analysis, right? So let's try and take this and move on with this. So how do you do that? Okay, so the plot that I've got here, if you look at this plot, as I said, I was zooming this up here. This is telling me, okay, it's taking a bit of time here. Okay, it is telling me this is your Q1, Q3, which is again pretty similar in both the cases, right? So there actually does not seem to be a lot of variation here in the data. So the Q1, Q3 is almost similar. The mean is almost similar, just about there. And the variation again post the mean is also pretty same. So you see here that there does not seem to be a very specific trend in the data for people who have taken away the money and who have paid back, right? So both of them lie in a certain range. Both of them got a certain median, and you really cannot say, okay, people with with lower amounts will run away, or people with higher amount will actually run away. What there's nothing of that sort, right? The In terms of people who have run away and who have not really run away, the relationship does not really seem to be very significant. It seems like it could happen at both the cases, right? This is what this box plot actually tells us. Okay, so you need to be able to interpret what it means and then do the analysis, right? Similarly, let's do one more. Suppose I want to do, say, data dollar loan dot status here, again taking continuous data only here, and so this is the categorical data. This dependent on set term of the loan, right? Let's take this data dollar term. Okay, if I draw and plot here, okay, now you see here, this is telling you some kind of probability here. So people with, okay, so people with long term seem to have a higher percentage, higher chances of taking the money and running away. Now this is what you see, right? To be able to verify this difference that you see here, right? For one it is say 0.227, for other it is somewhere around 0.4, right? So you would want to understand whether this difference between the two, is it significant to be able to consider in my observation that, okay, people with long term loans have a higher chances of running away, because this is just a small sample data. Will it hold true for the population or not, is something which we'll have to understand by doing the t-test or a z-test. Okay, or so this is both are categorical in nature, so we'll have to do a chi-square test there. Okay, fair enough. I'm not getting into that again in the interest of time for now. Similarly, if you have to draw another plot, say, for, instead of term, let me take say, okay, this years in current job, right? It has been taken as a categorical data. Okay, I need to check what is the Okay, let's directly see. We'll get to understand what data it is, considering it to be. Yeah. It's a touch slow here. Years in current job. Years dot in. Sorry. Current job. Sorry. Yeah. Leave this for now again. Okay, now it is giving me a different curve here. Now if I try and plot it here, so what I've really taken, years in current job I've taken in one column. Right here I've got this is for fully paid, this is what it is. For charged off, this is what it is. Okay, let me again, seems like not really readable here. I can change this as well, right? I can decide which one is my x-axis and which one is my y-axis. I can certainly do that. And I put a comma here, I'll put this here and run this again. Maybe you'll be able to understand this graph a touch better than what we did for the previous one. Right, maybe now if you see this graph, we'll do one for, so now this is both categorical, right? So again, you see there is some difference in the one which are 8 years and say 2 years, which have a little more, more chances of being defaulting uh, than the others. So again, you'll have to understand whether this is significant or not using a t-test, right? You'll not be able to do the analysis without that. Now similarly, if you take both the two variables as continuous, right? Again, I'm drawing a scatter plot, and with that scatter plot, I'll try and understand that. So data dollar current current loan amount, comma data dollar say credit score. Sorry. Okay, these are both categorical in nature. Sorry, continuous in nature. Now if I draw and plot, again I can do various kinds of plotting. I'm restricting myself to a simple plot here. Now, right? If you see this data, it really does not make sense, right? Correct? You don't see any trend here, isn't it? So if there is no trend here in this data, you don't see any, linear trend here. Seems like a pretty uniform distribution. So, across the range, you have all kinds of values, which really would not make a lot of sense. If I had to do with some other variable, say, okay, another variable could be annual income. Let's see this current loan amount and annual income. Do they have any relationship with each other or not? You'll be able to do that analysis here. Okay, now if you look at this data, there seems to be a trend here. So as this increases, this you can, I mean, if you try and draw a line here, probably you could draw a line here, right? Now this could have been a curve as well. This could have been so many things, but this seems like as this increases, there there is a relationship. There's a linear relationship here. Again, you can know more about this relationship if you do, I know, the further study on this. If you do correlation on this, try and figure out what kind of relationship is there. You'll be able to do more on that. Okay. So you can draw a lot of scatter plots. Again, you can do chi-square test. You can do t-dot test. These are the functions which are used. You can use chi-square test, t-test. Right. This is the chi-test. How do you do that? You do t-test, and you also do the you can also do the correlation, right? So you can do correlation between the two variables, whether there's what kind of correlation exists between the two variables, and then it will tell you the extent of correlation, right? So if you say this is the correlation between, say, these two variables, control C. Now let me just pass that up here. So this will tell you the the extent of correlation you have between the two variables. So it lies between -1 and +1 and has certain values. So if it is so plus sign and minus sign only tells you the extent of correlation, and the values that you have here will tell you the so plus and minus sign will tell you whether it is positively or negatively correlated, and the plus this value that you have here will tell you the extent of correlation, right? So on and so forth. You can do so much more, right? The more you, again, there's so much more which can be done here, but again, I'm restricting myself in the interest of time, which we really did not have. So hopefully you got to understand a bit more how you go about doing a certain analysis on data. It really not, in the interest of time, we tried to do whatever we could, but hopefully you've got some kind of understanding of how it really works. Just quickly, anybody has any questions, any queries, any problems? I'm okay to answering that now. No, I said you can do it between two. So if you see here, my dependent, and so there's a question: does it always have to be between dependent and independent? If you see, current loan amount is not a dependent variable. It's not a dependent variable. Dependent variable in my case was the loan status, and I've taken relationship between two variables which are both independent, right? Okay. All right. Any other question? Anyone? Sudhir, go on. You had a question. Go on.
Sure. Yeah, I just want to know what is the application of machine learning in in healthcare industry, and
I mean,
what is the future going forward?
okay, it's tremendous. I mean, you can just name it. So people are trying to do a lot of genomics. They're trying to understand clinical research, drug repurposing. You think about an area where you'll try. I'm so drug discovery is such an important part there, right? So you don't want to work on all the molecules. You want to discard a certain molecule. Why would you discard that? Again, based on the patterns, and you saving millions of dollars there. So across health industry, in pharma, in patient monitoring, in your you know in your clinical research, in clinical trials, in your you know uh, disease identification, pattern identification for disease. I mean, you name it and it's being used. So healthcare industry is one of the most prominent user of machine learning and data analytics today. So that
Okay.
industry
Uh,
is where you can
hmm,
look ahead.
okay. So I come from an US healthcare,
Okay.
IT background.
So again,
So
with this
s-
Obamacare, I think gone now, there'll again be a lot of focus on this, right? So Obamacare is gone now, right? They're not, and there's a rule, I think, which Trump has brought up. With Obamacare, there was a lot of with Obamacare in there, which there was a lot of pressure on U.S. healthcare, the industries to shape themselves up. Now with that gone, I think, things will start moving. There'll be a lot of investment which will come up, especially in these areas.
okay. What is the career path ahead? Considering that you're learning new technology, new tools, and things like that. What is the career path
See,
for an
somebody
a
who's
fresh
working
graduate
somebody
like
who's
that?
working in a certain domain. Say healthcare is a domain specific thing, right? So you understand that domain well. If you're able to apply a lot of statistics and patterns in that domain, you're able to bring that much more efficiency into the system. So I did not talk about why we are using data science today, right? It's primarily because there's so much efficiency and adaptability which needs to bring into our systems and across processes. And with the existing technologies that we have a lot of challenges, right? We only can get to a certain level, and that efficiency improvement is required or is a must for us to grow. So that is where the challenge lies, and that is where the new age technologies like big data and analytics and they have come up, right? It's not that they're new, they've been there for ages actually, but the usage has become prominent. Everybody is trying to use that because they now understand without this will not reach anywhere. Getting it?
Okay.
So
And
across
are and
okay,
yeah,
go.
sorry, go ahead. Go ahead.
Okay, so I was saying that all the IT companies and the analytics companies, uh, if you talk of that, right, the past 5-7 years, the talk has already been always been into these things, into big data and analytics, digitalization, right? Uh, okay. Okay, I have a question here. Okay, I'll take your question, Sudhir. I did not get what is RPA. Sajid, if you could put that up, I'll be able to explain that. Yeah, Sudhir, in the meantime, you can go ahead with your question.
Yeah, I was asking about is R Python an open source
Both are open source.
analytic?
Both are open source.
Okay.
Okay. See,
So the inclination towards open source is quite obvious, right?
correct. And I mean, again, and
Cheap
it's not just cheap. There is so much ability. I mean, R is so good. If I tell you, SAS is allowing you to write R codes in it. I mean, SAP is allowing you to write R codes within itself, primarily because they know the kind of functionality which R brings. They'll, if they try and replicate it, that still will take a lot of time for them. So why not just allow R coding to be run in their systems, which is again free of cost, available free of cost, right? So that's where things lie. Okay, RPA is robotic process implementation automation. You're saying. So see, when you talk of robotics as a term, uh, you know it's okay. So if you talk about machine learning and analytics, robotics, I really don't think so. Process automation, obviously, it's something which is at the heart of the entire change that we are seeing. So do you have a lot of sensors being put up? You have a lot of devices which are being put up, which generating a lot of data, right? In terms of robotics, you say okay, there's a the whatever a human is doing, that is being done by a machine. Um, that's something which is more towards only certain mechanical part, or more into the industry, which primarily manufacturing, you can talk about it. Or I don't think robots will be in a position to do an operation, although you talk about that in
Yeah.
healthcare. But that's again, ages away. That's still far away,
Eh,
right? So you saying something, Sudhir?
Oh yeah. I mean, the question seemed not directly relevant to what we are discussing
Yeah,
about.
but
So
still, I'm just trying to
just tell me.
explain this. So
Sure,
robotic
sure.
process automation is an entirely different thing. But
Exactly.
in terms of process automation, if you talk about it, there's a lot of stuff which is happening to understand the patterns and make sure that actions are taken beforehand. So for example, if you talk of electricity grid, right? If you talk of the entire grids which are in there, and the entire grids fail because there's so much load. So can somebody see the patterns which is emerging, and whenever it becomes a little too large, you drop off few things. You
Proactive. Okay.
Proactive, correct. So something of that sort, again, based on patterns, machine is going to adopt that and do that. Based on patterns, you try and understand. There's a lot of data collection, right, because of sensors now. So how the electricity is flowing on both the directions. Now you have inflow and outflow. If you know about utilities industry, and there's a lot of solar panels and stuff being put across the world, right? So you're not just taking the energy from the grid, you're actually feeding it back to the grid as well. So there's so much which is happening in there, that you need to know more about these things. And machine learning per se is all about finding efficiency wherever possible. So robotics, frankly speaking, I'm not really too aware of it, but from the outset, the way I see it, I don't think machine learning can really uh, I mean, you always say, in terms of robots doing a human job, that is where AI brings up, and that uses a lot of machine learning. But that is something which goes beyond machine learning as well, right? So that's the next step to machine learning. uh, okay, all right, any other question, anyone? Okay, have you filled up the form, guys? Would be really appreciable if you could do that. uh,
Kush, just another question.
yeah,
Uh,
one sec, there's one.
now you understand that
So
we some of us who are joining this session are completely new to this,
correct.
and as well as they come from different domains.
Mhm.
Now, what is the most what do I say? How should one take forward this as a career, or how easily or how hard is it to
Okay,
transition
okay.
and
Got a question.
dedicate
Got
the rest?
got your question. Sorry to interrupt you there. Okay, so I have a
Not a
couple of
problem.
I've got a couple of things. So there's one question: what is the support you provide after we complete the course and for how long will that support be? And then so this question, which is, should you actually transition to data science or not? How difficult or easy it is, right? So anybody who's trying to get into data science, you need to give yourself about 5-6 months bare minimum, right? And that much time frame would be good enough to learn and understand at least the foundation pretty strong, right? You'll be pretty good on the foundations. And in terms of whether you should transition or not, I think uh, okay, Sunny, I think there's some problem at your end because everybody else got it. So maybe I can drop you a mailer with everything. You can have a look. Coming back to this, so in terms of whether you should transition into data science or not, the transition has to happen. Again, I said the only prerequisite: are you somebody who is comfortable with numbers, who is comfortable with problem solving? If you're of that bent, I mean, understand it's not that you're switching yourself directly to data science. You are adding an analytics as a or ability to work with data as a very important skill set to your profile. So people who are working with SQL, with databases, with BI, with any kind of analysis on data, they certainly should do it, primarily because for them the next logical step is that, right? Otherwise you're stuck in a spectrum. If you want to move ahead in your spectrum, you need to move ahead and do predictive analytics because the world is moving towards that, right? Maybe in 5-10 years we'll still be doing a lot of descriptive analytics, which is reporting the data, but slowly and gradually that would get automated, and you would want to do more of predictive analytics where your human brain will be required much more. Okay, that's one point. Now, Sudhir, I think I've answered your question, right? So whether you come from any domain is obviously, does play a part, but adding, don't consider that you're moving to a data scientist role tomorrow. Understand that you need to get to a certain level, and you're adding this as a very important skill set, and with more practice, with more cases, with more understanding, with more analysis of that, you'll be able to get to a level where you're able to you know say that, okay, now I'm not just doing a job which is assigned to me. I'm moving much more ahead. With that, I'm doing a lot of proactively. I can do so much more for you as a client. Just think in that terms. You're trying to solve a business problem proactively, which you will not be able to do now, right? Okay.
Absolutely. I mean, Kush, what you're learning, what I'm talking about is that broadening a spectrum is definitely one of the things
With
that
data
that can
science,
help
that data science
you
is something
enhance you.
which is a very, very
But
important thing. That is where, that is where the future lies. So why, if you're widening, why not widen in data science? Because that is where your entire jobs will move to, right? That is where the things are moving to. Why to move into some other direction? Okay. So Sudhir, I'll come back to you in a while. Just give me one sec. So I had another question, which was,
sure.
for how long will I support? So I'll just quickly brief you on the course that we offer. So we'll be covering a lot of statistics. We'll be covering a lot of the tool, both R and Python, whichever you want. You want to start with one, you want to do both, you can take that. So 30 hours for each tool. Machine learning is something which is very critical. So I'll spend a lot of time doing a lot of case studies on machine learning. And again, I'll make you do it in the class. I just don't want to give you a lot of theory and just say, okay, done with it. I would want you to do a lot of practice with a lot of cases, right? That is where the actual impact will be. In terms of visualization, I do Tableau generally. Those who want to add to that, well and good. If not, okay without that as well. SQL again for 10-15 hours, which is again a complementary module to give you very basics of SQL who are pretty new to this field SQL, right? A lot of you might not be doing that. Then once you're done with it, you work with real-time project. It'll give you a lot of case studies to work with, which are from Kaggle and Crowd Analytics and certain websites which host a lot of data science competitions. And when you do those cases, again, the complexity level of those cases is not pretty simple, right? They're complex cases, and when you do 4 or 5 such cases, you'll start believing you can know data science well. Okay. And I have a real good focus on this part, because I know doing a course is okay until unless you implement it on your own. You're not reaching anywhere. So it's important that once you're done with things, when you've learned things during the course and after the course, you try and learn, do more analysis on that. That's something which will be important within data analysis. So we R will be a very, the way Sudhir is talking, I'll allow you to talk in the sessions, uh, give you a lot of chances to speak. It's not only a chat based thing. For me, it has to be a lot of hands-on. It has to be an individual attentive basis, and all of us, as I said, are IIT grads with decent amount of experience in the industry, so you'll be able to approach us anytime, anywhere. So I think Saurabh called me today. I missed his call. I gave him a call back that, Saurabh, I missed your call. So I will be approachable. Others will also be approachable. You'll be able to talk to us, get your queries solved. Okay. Then in terms of support you had, so you'll have 1 year support after the completion of course, Saurabh. So that you have any questions, any queries, you can always come back and ask us. We might not answer it straight away. I might take a day to answer. I might be busy somewhere, but I'll certainly come back and answer your question. Okay, that will be there. Since it is an online instructor-led live session, all the sessions will be recorded, and the recordings will be available to you. For 2-3 years, 5 years. So it's generally 2-3 years is what we generally give it, and that time is good enough for you to move to the next level, which so you really don't require those recordings after that. So primarily that is why we say it's lifetime, although you can always come back and say, Kush, I need that. I'll not say no to it, right? We would want you to attend all the sessions live. If you miss a session, you can again come back and do that session live in some other batch as well. Okay, in terms of a lot of people have this question, I'm trying to transition. So how do I do I just say that I've done a course and I'll be able to transition? No. So that generally does not happen. You do not say that I've done a course and people will take you for a job. People would want to understand your practical insight, practical knowledge, right? That is where you'll be able to uh, you'll be able to transition. So whatever you're doing now, I'll try and see what you're doing. I'll have to build a story. I'll help you build a I'll help you do a lot of case studies. As I said, some of those case studies will go into your resume as projects, right? That will be very, very important. And once those become your projects, your profile builds up. You can talk about that profile. You can say, okay, I have done these 10 things. Let's talk about this, right? And if you really spend time, and it's not that you'll be able to do one case in one day, right? As I said, we've done 2-3 hours and still at the pretty starting univariate analysis level only, right? So if you do about if you do about 3-4 hours daily, you'll take 10-15 days to get to a level where you'll be able to talk about that case for an hour. At least that much you should reach, right? And again, you'll do a lot of you'll be falling, you'll be learning, again you'll be falling, you'll be learning, and that is where your depth will increase. The more cases you solve, the better will be your depth. The more answerable you will be to the better you'll be your answers to the interview, right? That's one. So it'll help you build your resume in terms of a storyline, what you're doing, plus case studies from your domain, which will add value. And then we have a referral network, will help you get through the jobs through the referral network. And then there are a lot of case studies, as I said, companies will give you, will help you solve that as well. But generally people are able to solve it because we've taught them well. So for us, teaching well is more important than spoon feeding all the time. So initially it will be a bit of spoon feeding once we're making you learn. Once you start getting confident about yourself, we'll start leaving you on your own. But it's not that we'll just leave you. After the course also, we'll keep giving you cases to work on. And when you've done 3-4 cases, your confidence level is actually very, very different, right? So you'll feel, okay, I give me anything, let me try and solve it. You might fail, you might learn, but you would know how to move ahead with that. And for us, that is very important. I cannot teach you or tell you the entire ocean. I can tell you, okay, this is how the river is, or this is how the pond is, and this is how you need to swim. Then to explore the entire ocean is your job, right? So I'll give you whatever is mandatory, which will give you enough ammunition to go out there and crack a data science job. Okay. Okay, then this is our LMS, will give you access to the lab, access to the recordings and everything. And okay, that's it from my side in terms of what we do. And as I said, the batches are online, instructor live sessions, the way we are happening now. Similarly will happen there as well. Okay. Now if you have any questions, I think I answered your question. Any other question anybody has? Yep, Deepshikha, Kushal, Padmini, Ravi, Sajit, Sudhir, Sunny, Vasudevan. Any questions, anyone?
Hello, Kush, am I audible?
Yes, Sudhir, go on.
Hey, hi, Kush. So I think I missed out on the prime introductory session, and I'm sure that you might have introduced yourself and
Okay, so I
You've spoken about your background, background and the years of experience, what you do and what's your job profile is. Can you help me with that?
Okay, so okay, quickly, my name is Kushagra Singhania. I'm an IT Delhi graduate with about 10 years experience in the industry. Primarily worked with a lot of predictive analytics, and even now I'm in this organization. I'm one of the founders of this organization, and we've been doing a lot of consulting, and we're primarily doing a lot of training people on data science, right? So that is what we primarily do.